the way I use the decimal gives me. Turn it into a
Alright. Good afternoon, people. 3.2 it is.
makes a number instead of a fraction.
What we did yesterday is we learned about polynomials. Poly means many x's raised into powers with numbers in front, added and subtracted. That's it. They have basically two shapes, either U-shaped or inverted S, one side going down, the other side going up. But you may have upside down U-shape depending on the sign in front. But if it is positive, either one of these shapes is what x raised to power is. These shapes is going to make our end behavior for a polynomial with more terms. So if you have not only x to the 4, for example, and something as 3x cubed plus 2x squared plus minus 10, the middle side will be a roller coaster shape. At the ends will either both go up, both go down, or one side up, one side down. There are 4 options. Okay? We have found that you don't have to memorize this table, by the way. If you know the previous page, this one, you can make those two ends. Like in this one, we found out that it was positive x, positive 6x to the 8. Yep. This was starting with 6x to the 8 and something else. How did you get it? You basically multiplied all x's with powers. So I got 6x to the 8, and I know that x to the 8 is U-shaped, something like this. Since it's positive, it's the regular orientation, so I knew it was going up and up both ends. Or this table also tells you that since n is even, 8, and coefficient is positive, both ends on the far right and left goes up. Okay? If it's going up, it's infinity. If it's going down, it's negative infinity. Alright, I believe we also mentioned the zeros. Zeros doesn't mean number 0. Zeros are actually maybe other type of numbers, whole numbers or partial numbers. But when you substitute them into equation, they make the equation 0. That's why they call 0. And if they show up multiple times in a factor, like 3 times x minus 2 shows up, that number coming up from that factor has multiplicity this number, such as minus 4. Opposite of this number is the 0, and it shows up 7 times, so it has multiplicity 7. And we were about to sketch one final polynomial, and we're done with this section. But as I gave you a preview last time, we are going to do 7 steps, and pretty much we are going to review what we learned so far about polynomials, and also earlier sections like symmetry. Okay? Okay. Any questions before we start today's class? Alright, let's start. What do we do first? It says, number 1, use leading term to determine the end behavior of the graph. Which one? There are only 2 terms here, this and that. One of them is leading, which is 7, the one with the biggest exponent. So leading term is x to the 7th, and I know that x to the 7th has a graph. It's odd, so it's not U-shaped. This graph is something like this. So the leading end behavior of this graph is on the far right end, it's going to go up. On the far left end, it's going to go down. Okay? Every time we copy this step list, put it into the picture. Put that result into the picture we are supposed to make finally, so that we don't lose track of the data. So right now I found out that my graph is going to go like this on this end, and like that on this end. Okay? How do I know this? Because I know the graph of x to the 7th is like this from the second slide. Okay? Odd numbers have this kind of shape. Well, is it going to be smoothly rising in the middle? No, it can be a roller coaster going up and down. We'll determine that by the other steps. Any questions so far? Okay, number 2. Determine y-intercept. You don't have to say this. I already know how to determine y-intercept, right? By entering 0 in x, we need to set x value 0 in the function. So I'm going to set 0 into the x and compute this. And what do we get? 0. 0 raised to any power is always 0. So when you subtract 0 and 0, it's still 0, right? So y-intercept is 0, 0. I remember back a couple of weeks back, I don't know, last week probably, I told you if you end up with 0, 0 in either x-intercept or y-intercept, you already know the other intercept as well. 0, 0 means you are meeting x and y at that point. That means both x and y intercepts are actually 0. So in number 3, I'm going to find x-intercepts, but I already know one of them. I don't know how many, but at least one of them is 0. Well, let's find out. How do I find x-intercepts? X-intercept, by the way, another name of x-intercept is zeros. By finding x-intercept, they're actually asking for zeros. And how did we find zeros here? By setting each factor into 0, but before that somebody had factored this thing for us. In the previous question though, this wasn't factored, and we factored this yesterday, remember? We found, I don't know how many pieces, we found at least 2 pieces that factored into. So first thing in finding x-intercepts is, set y into 0. X-intercept means 0, so you set y value into 0, in other words, this whole thing. But you guys need to factor it. Factor, factor, factor. Perfect. I already see a lot of x's raised into powers, right? 7x here, 6x here. So I can pull some of them in front, and it's 6 of them matching. So x to the 6 can be pulled from both, and there will be still 1 left if you borrow 6 of them on the left. On the right, there will be none left. So it's going to be only 2 left. Okay? Alright, to find out zeros, you need to set each factor without the exponent though. I don't need to set the exponent into 0. And if this would have a power, I would ignore it as well. Just set the base into 0. And this is already answered, but this one needs to be solved for x, which is simply 2. So there are 2 zeros, but they don't have the same strength. What do I mean by strength? I mean multiplicity. This 0 shows up in this factor how many times? We call it multiplicity. What is the multiplicity? Multiplicity 6. This one is multiplicity. What number do you see here? Nothing? That means 0. It's 1. Multiplicity with 1. Okay? This one is 1, this one is 6. Alright, we're done with step 3. I'm going to now carry the information we got number 2 and number 3 both into the picture. That's actually what it says here. In step 4 it says draw what you obtained so far into the picture, but I've been doing that already. We just didn't do number 2 and 3. Let's do number 2 and 3. So we got in number 3 the intercept, y-intercept was 0, 0. In number 3 we found x-intercepts, 2 of them. One of them also 0. I promised you it's gonna match to earlier result. The other one was, what was it? 2? 2. So 1, 2. 1, 2, 2, 0. 0, 0. Alright. I can kind of visualize what's going on here. But your feelings, intuition can be wrong, so don't decide too early. Wait, get more data. Let's get more data. I have a feeling this is gonna go across this, come down, cross that. Let's see. Number 5 it is. We did number 4 on the picture. We're on number 5. Number 5 is something new we need to learn. It says sketch. However, when you are sketching it, don't just go with your guts. It says use multiplicities. Remember, I put these multiplicities down, but I haven't used it in the picture. Now we are going to use it. What does this multiplicity say? If a 0 has an even multiplicity, even number. Is this an even multiplicity?
Yes.
It's an even number, right? Then what does it do? You are going to, when you are going towards that crossing value, you are only going to make a touch and, but not cross, just bounce back. Just like a ball. You throw a ball to the wall, it bounces back. It touches and come back. That's what I'm going to do. Where, when, where, here. Touch and bounce. Bounce back, or no crossing, no cross. Okay, let's do what I said. We are going to go from all the way left to here. I'm going to touch this point, but I won't cross. I will not cross. So come here. Touch it and go that way. Is that true? No, it said don't cross. Touch and bounce back. So I'm going to touch and bounce like that. Just like a wall. You're hitting the wall coming back. Okay? Now, what was the multiplicity of this one? This was multiplicity 1. If you have multiplicity 1, that means odd. So this was even multiplicity. You touched and did not cross. This is odd. Guess what you're going to do?
Cross.
We are going to cross. Yes. I don't even need to read that. I already figured that this needs to be crossed. And guess what? We are going to meet that end. Yeah, it's a little bit off, but we fix it. It's these ends. It needs to be really sharp because it's high power. Leading behavior was x to the 7th. It needs to go really sharp like that. And really down like this. That's better. It's more like it. And don't forget to make double graphs here, okay? I'm kidding. It's just my poor sketch. Alright, so we're done with this one. Okay, what is number 6 and 7 then? I already sketched it. Question is over. Really, yes. These are kind of optional. Okay? You do not have to make these. This is for assurance. Double checking. Whether you made a mess or not. Okay? For example, we are testing here whether it's even or odd. What is nice about even functions? What do we call functions sometimes even, sometimes odd? What do you expect to see in their graphs, so we call them even. It says here, even functions are called even because their graphs are symmetric with respect to y. So if you fold it along y-axis, they coincide. Does this look like an even function? Is this even? No, I expect to see this piece on the left side as well then. It doesn't. So probably it will not be even. It's not gonna be even. How about oddness? Odd functions will have symmetry with respect to origin. Does this look like symmetric with respect to origin? This point must be reflected along origin, and it needs to be here. And your graph should be crossing it here. It's not odd either. How do you verify really this? I can see it from my result. I'm not expecting to get either one. It's a neither case. But let's do it anyways. You need to compare f of x, this is 6 by the way, f of x and f of minus x. Really, compare f of x and f of minus. F of x is, or in other words, our function is, what is it called? It's not f, it's q. This is q of x and q of minus x. Q of x is already been given to you, no brainer. You just need to copy it. But you need to compute q of minus x, which is this. And see, you have two options. If they end up being equal, if they are equal, we call it even function. It has y symmetry. If they are equal, I don't know, question mark. If this one is opposite sign of this, it's minus of the original. Minus of the original means each and every term will be opposite sign of this one. Opposite sign, then we call it odd. There is one way to figure this out. Compute this all the way. I mean, take care of these minuses. 7 times negative, what does it make? Take a negative number, multiply it 7 times. What is the result? Positive or negative? Negative. Odd, many number, negative number, still negative. So this is negative x to the 7. Negative out, x is still under 7. How about even power of a negative number? Positive. No, not that. That subtraction is still minus. This is still minus, but this thing is positive. It's just x to the 6. No more minus sign. Gone. That one is gone. Now compare this to that. First off, are these things equal? I have negative x to the 6, negative x to the 6, okay, half of it match, but the other half, first one, doesn't match. They are not the same, you cannot make them the same. Sorry, it's not even. How about oddness? Is this the opposite sign of this one? Let's take opposite of this one, quickly on the spot. So this is going to be minus, this is plus. Did you hit that one? Now almost minus, minus, plus, minus, nope. Even though I switched the sign, I'm still not getting it. This is not true either. So it's not neither odd nor even. It's just we just wasted our time. But we already knew it, right? We were expecting it. So I'm relieved because my picture is possibly right. That's why it fitted to the answer, right? I would be worried if this was even and I get no even in the test. Okay, what is number 7 now? I said these are optional, but they're good practice if you have time to do it. It just says creates a set of more values, plot more values by setting at the table like this and computing x and y's, x and q of x's, such as plug in some values between these red dots and a little bit beyond these dots to the right and left, such as take -1, +1, and 3, for example. These are good values. -1, +1, and 3. And compute them. it's gonna give you a better picture. For -1, you substitute -1 for what did you choose the other one? 1? Was it 1? And 3. And compute this, please. I'm not gonna do this, okay? Compute. It's just gonna give you a better idea how deep this cavity is. Maybe if you find at 1, if it is -10, you need to go really this deep, okay? If it's -10, plug in 1, and if you're getting -10, yeah, you shouldn't become short like this and go really deep down, okay? So it gives you more precision if you try some values. But I'm feeling okay with this picture. If it's a little bit down, I can still spot it in the options. So let's enter our results to the homework. Any questions though? I'm a little fast, but any part you didn't get? I mean, there was absolutely nothing new except number 5. We tested crossing and touching points. This is new stuff. But I think you got it. If it is even, you touch. If it is odd, you cross. Okay. Both left side was down, right side was up, right? The function has how many y-intercept? A function cannot have more than 1, by the way. So it's ridiculous to choose 2. It has 1 y-intercept. And that one was 0, 0. And function had how many x-intercepts? Zeros are x-intercepts. 2. And they were 0, 0. No, they are not asking it. Okay, they're not asking directly. Which one fits into my picture best? You see, this is really taking a dive here. And it's really flat in this area. That's okay, we almost got the right picture. So it looks like, which one is the best choice? C, right? It's the C. That's it? Yeah, that's it. Okay, that's it. Any questions? No? Alright, this was just a starting section. And the next section, we're gonna analyze these polynomials more, especially focus on something called zeros. Those zeros finding procedure. Oh yeah, it wasn't that easy all the time. You factor and set it into 0, kind of too easy. We will see more challenges, but no, it's not really too difficult. You just need to pay attention to a couple of things. All right. In 3.3, we need some weapons first, right? Weapons to fight for those struggles I mentioned, zeros. Finding zeros is gonna take a while. So we need to first gather some weapons. So one weapon tool we need to learn is division, polynomial division. And there are 2 methods for this. First, I'm going to explain long division method. This method understand from the name, it takes it takes a long time, kind of tedious, long time, but takes care of any kind of division problem. So there is no problem this method cannot handle. All the problems can be solved by this method. Use anytime. The second method I'm going to tell you is, let's fast forward to there, syntactic division. Oh, you're gonna love this, it's fast. However, everything in life that's too good is limited. Alright, you can't have too much dessert, okay? Right? You get sick. Now, what is the limitation? It only works with divisor, those divisors should be this simple. That means there is no square around the x. It must be only x and a number, either minus or plus. That's it. It only works with very simple divisors. Number plus minus another number. If I have a square here, sorry, you can't do synthetic division. You need to do long division. So you guys need to know long division for sure. This is optional, but I want you to learn this because this is fast. This is most widely what's going to be used in finding zeros, coming up very soon. So you need to learn both. But if you need to forget after this semester, if you want to forget, empty some space in your brain, forget the synthetic one, but keep this in your mind, long division. Okay? How does this work? It's rinse and repeat, same procedure over and over until you run out of numbers. What procedure? I describe it here. I'm going to apply it, and you will learn on the way. Okay? First, you need to set up your notations. Here is the division notation I use. By the way, how do I know this is a long division operation? Do you see this symbol? It means divide. So that's why I'm doing division. It actually says divide. But one of these polynomials will go inside here. This is the room for dividend. It's called dividend room. Dividend. I'm not sure it's with a T or D. What is it, D? Dividend, I think it's D. Do you see it? Oh, it's with a D, of course. Alright, this room is for divisor. And this one is for the result. We call it quotient. Quotient. Okay? That's true, yes. Okay. Now, which one of them is called dividend again? The left side. The one you are dividing, the long and big one. Okay? This is your dividend. But you're gonna just move it here, right here. When you are doing that, you're gonna be extra careful. Don't take it in the given order. You may need to reorder these terms from biggest power to smallest. So which one is the biggest power here? So I take that first. What is next? -10. I forgot something. There is actually a power between 4 and 2. I don't see it here, but its ghost, its soul is still there. So you need to make it visible. X to the 3, but what is the coefficient?
0.
No, not 1. If it's 1, it would show up. It's 0. So you need to make missing powers visible by putting 0 in front of them. Sorry. They count as well. 0x cubed, then minus 10x squared. Alright, looks like I need more room. And what else? Minus 24?
0x.
Yeah. Before the constant, you need to have drop to the first power, x to the first, but I don't have any x term, so it's 0x. And then 24. It turned out longer than it looks, right? Are we good so far? So you not only move it, you also fix it on the way. Alright, divisor is this thing. And this one needs no fixing because it's already in the right order and every power is visible. Okay, this is the setup. We haven't started yet. We just set it up. First, you divide the leading term of the right with the leading term of the left. What do I mean by the leading term? You take a color pen and circle the largest exponent, largest power on the right. Which one is it? First one, of course. When you order this, first one is the largest. When you circle the largest of the left, it's always first ones. What do you do with them? You divide one into another one. So step one, if you want to call this one, we divide 4x to the fourth by 2x. By the way, before we start, how many of you guys have seen this before? Raise hands. Oh, pretty good crowd. So you guys are okay probably with this, but sometimes overconfidence is costly. Just because you've seen this before, you go fast and make mistakes. So go slowly and follow all the steps I do. When I say divide, it's actually cancellation. One of the x's cancel and one of the 2's cancel. The result should be always something whole, in no fraction left. It's 2x cubed. And what do I do with this 2x cubed? Step 2. We multiply the divisor with this. You put 2x cubed, take a parenthesis, put the divisor, multiply by this. 2 times 2 is 4. X cubed times x is x to the fourth. And I have just 4. Happy? I just multiply 2 times 2, 4. X cubed, one more x joins to cube, makes 4. Step 2 is over. Yeah?
Question. If you're just going to divide it and then multiply the 2 back in, why would you... never mind.
No? You're good? So I divide this, get a result. That result multiplies this entire thing. There is a problem with my method.
4x get multiplied.
Austin.
4x get multiplied by 2x to the third.
Right. You not only multiply the first one, but also the second one is distribution. So 4 times 2x cubed makes 8x cubed. Yeah. Okay? That number is not just 4, it's 8. Okay? Now, what do I do with this result? Oh, by the way, before going to step 2, I missed this important step, and it always gives me a headache later. This result you found needs to be first recorded. You need to go record it here in the quotient answer location before you forget. It's not a mistake, but if you forget recording here, then it mess up, okay? Next, we're not done with step 2. Step 2 actually have a second part. We get this result subtracted from the dividend. So I'm going to subtract that from this. Okay, here, watch out. Mistakes will be raining right now because during the brush again you do this involuntarily, but it happens. 4, you're subtracting another 4 from it, so it drops to 0. This thing is 0, you don't even need to write cancel. Perfect. And then you just take 0 and 8. What is 0 plus 8? It is.
When does your class end?
I'm sorry.
When does your class end?
135.
1:35. All right, I'll be back.
Uh-huh. Alright, 0 and 8 makes 8x cubed. You have 0x cubed, you add 8x cubed, right? Right? No. During the rush, you ignore that. You were doing a subtraction. You forget about this and start adding. 0 plus 8 is 8. Because when you learn synthetic division, in synthetic division we will add this, not subtract. You start confusing, but don't forget, this is subtraction. So you actually have 0 subtract 8. So you need to flip this sign. 0 take away 8 is minus 8. Okay? Actually, this is what I recommend. Before you start your subtraction, flip all the signs, like 4 becomes minus 4, 8 becomes minus 8. Then start adding things. 0 minus 8 is minus 8. If there was something underneath, I will add them after flipping the sign. Either flip the signs or don't forget you're subtracting. Alright, what do I do with the rest though? I don't have anything underneath them. Nothing. Void. You just transfer them down here. Because there are nothing in 0x squared, 0x and 0. So they will not change at all. Are we gonna flip their signs though? No. We're not subtracting from them. It's the first thing. So they don't change. Okay, this was one application. This is what we did. Step 3 is here. Step 3. This is one application of the method. Are we done? Is the process over? No. We will keep repeating this over and over all day. Until when? When do you understand? When do you stop? When do you guys understand? Oh, here is the last step. I need to stop. What is the test for? For example, shall we stop right now? How do you know when to stop? Who's that? We need to get only a number on the end? No. You can stop earlier than that sometimes. That's not it. You're close. When we have a leading term power less than this leading term power, that's when you stop. And you're actually right in this case. Since this is single power, if it drops beyond lower than 1, that means x disappears. We are going to continue here until a number obtained. But sometimes if this is, for example, 3, then you're going to stop when you get a power 2. If this is a 3, you're going to stop when you get a result with power 2. It's always 1 less than the leading power of the divisor. Okay? But since this is 1, that means I will keep going until all x is wiped out. Alright. Okay, let's do it one more time. 3 steps. Okay, I will just take a gap and redo 1 and 2 again. What is 1 and 2? This is my leading term. This is still my leading term of the left side. I will divide them first. Minus 8 x cubed divide 2x. What is the result? Negative 4 x squared. Perfect. And before I forget, I need to move it here. Negative 4 x squared. Second, we go multiply this with the divisor. What is the divisor? 2x plus 4. 2x plus 4, yes. Alright, let's multiply and subtract quickly. negative 8 cubed minus 16x squared. And I subtract it from here. Negative 8x cubed minus 16x squared. Subtract, cancel, cancel. 6x squared. Am I right? Double check. Is it 6? Let's make this sign visible. It's negative, right? This one will turn into positive when I subtract. Minus minus makes positive 16. Negative 10, positive 16 is positive 6. Right. We will go 2 more rounds, so let's speed up. Biggest power 6x squared. Divide by 2x. It's 3x. Multiply 3x by divisor 2x plus 4, which is 6x squared plus 12x. Right? Then subtract. Look, I forgot something. Nobody's warning me. Good. I don't care. I end up with a wrong answer. No big deal. What did I forget doing? Cancel. This is gonna flip sign, become negative, and negative 12x, negative 24. And last one. Thank God, the last step. I will do it here. Take this guy, divide by the divisor again. Minus 12x, 2x. Oh, look at this. X's are completely gone. This is 6, negative 6. And I take negative 6, multiply by 2x plus 4. That's negative 12x minus 24. Oh my God. It's exact match. Were you expecting this? If they are, yeah, they are dividing each other. The remainder is 0 because you have absolutely nothing left. 0. Okay? Are we good? So what is the result? Result is this. When you divide these to each other, this is the result. Sometimes they will ask a remainder if it's left. There is nothing left. Remainder is 0. I will go try that and will be shocked that the answer is wrong because I forgot doing something. What did I forget? Yeah, I forgot recording my results from each step. Every time you do number 1, you need to record that into the quotient. 3x and minus 6, I forgot to record them. These two. I did the initial 2. I forgot the last 2 because I was just speeding up, rushing. And what were they again?
2x3 minus 4x2 plus 3x minus 6.
3x minus 6, right? This is the result.
Plus 3x.
Plus 3x? Yes, it's plus, thank you. Plus 3x. 2x cubed minus 4x squared. Look, they are all obtained in step 1. 3x cubed minus 4x squared. 3x and minus 6. Now this is really great. For the first time you will be painful to connect math. It's going to tell you you're right or wrong. In the exam you do all this work and you messed up in the first step. I cut off all the points. You never know you were doing a mistake. But no, I will give you points, but at least you have here something to check you're right or wrong. Alright, somebody read me the answer, please.
2x3 minus 4x2 plus 3x minus 6.
Okay. Alright, I understood why this was happening. When I put the pen here, still does it. There's another one? Oh, that does it. Okay. Nobody figured it out like that at the time. Or maybe you knew it, you didn't tell because you wanted me to cancel it, huh? That's smart. Okay. I'm not sure we can do this in 10 minutes. So I'm going to leave this to tomorrow. Why don't you give a head start tonight? You do this
I feel like I'm back. Friday.
Friday, yes,
I
right.
feel like I'm back in high school again. I remember this.
Me too.